Let's now see what happened at processor startup. When you turn on the power on your processor, the following reset sequence will be triggered. After the reset, the very first operation that your processor will do will be to fetch the data contained at address 0 in your memory address space, and that address contains the initial value for your memory stack pointer. That way, when you pick up that value, you'll be able to know where your stack starts in the memory address space. Immediately after that, we will fetch the instruction we'll fetch the data from address 4. Note that what we do is to go from address 0 to address 4 because we read word level data. And we will retrieve the so-called reset vector. And the reset vector basically contains the address of where your program will start, because your program can be located in different locations in your memory address space, and you want to know where it is when you start your processor. After you're done with loading the reset vector that basically saves that into your program counter, then you will read the address indicated by this reset vector, which is again the very first line of your program. And as such, you'll be able to fetch the first instruction of your program, and you keep going by following either the increment of your program counter or the branches instruction in your program. Let's review an example of what the memory address space will look like in our processor. You have again the representation of our entire memory address space, and as you can see, only subsets of this memory address space are accessible. Those are the locations where we have a physical memory attached to it. The memory being either an SRAM, a flash, and so on and so forth, different memory technologies. What does that mean? At processor startup, we'll look at the content of address 0. At address 0, when we programmed our microcontroller, we smartly put the address of our memory stack pointer, the initial value of the memory stack pointer. So as you can see, it contains this address that points to the top of our SRAM address space. This is where our memory stack will be located. After that, we will read the address 4 that does contain the address of the location of our program. In this particular case, we go to C1, and in C1, this is the address of our boot code that will end up being subsequently read and executed as soon as our processor will continue its execution. As a side note, once again, note that the stack grows downward, so you always point to the last used memory location, and then you'll keep going down in your memory organization.